Hello, my name is Arai. In this video, I will focus on the role of network layers. Also, I will cover how the communication between network layers is facilitated. Let's go! Network layer is the third level of the OSI model and the layer that provides data routing paths for network communication. It uses four processes: addressing, encapsulation, routing, de-encapsulation. In first process called addressing, each device in network is configured by a unique IP address. We know that data passes through application, presentation, session layers. In the transport layer, encapsulation starts, where data is encapsulated into segment, and network layer encapsulates segment into packet, packet into frame, and frame is converted to sequence of bits. Then this sequence of bits is transferred to a process called routing. Routing is the process of identifying the best path to a destination. When a source device sends a packet to a remote destination device, then the help of routers and routing is needed. To travel to another network, packets must be considered by routers. After routing, the previous sequence performs from bottom to up. When the data arrives to a network layer, the host here checks whether the destination IP address of segment matches with its own IP address. If it happens, then the encapsulation process performs. After the encapsulation, resulting PDU is passed up to transport layer to appropriate services. Your computer needs an address so that computers in the internet can send you a file that you want to download. That address in internet terms is called IP, which is a stream of numbers written in a certain format. IP address is of two types, IPv4 and IPv6. IPv4 is a 32-bit address. In IPv4, a unique sequence of bits is assigned to each computer. Therefore, the total of 2 to the power of 32 is approximately 4 billion devices. However, there is a problem with IPv4. All over the world we have more than 4 billion devices, so we are slowly moving to IPv6, which is 128-bit IP address. IPv6 is written in form of as a group of 8 hexadecimal numbers separated with columns. This is human-friendly form, this is computer-friendly form. Since a unique sequence of bits is given to each computer connected to internet, with IPv6 a total of 2 to the power of 128 can be connected to internet. That is, IPv6 can address this amount of devices, which is actually more than enough for many future generations. IP addresses can be classified as dynamic and static. Let's start with dynamic IP address. When you connect your device to Internet service provider provides you an IP address from the range of available IP addresses. Now, your device has an IP address, so you can connect your device to Internet and send and receive to and from the computers in Internet. Next time you connect your device to Internet, your Internet service provider provides you some different IP address but from the same available range. Since IP address keeps on changing every time you connect your device to Internet. So, such IP address is called dynamic IP address. Now, static IP address. It never changes and it serves as permanent internet address. Static IP addresses are used by DNS servers. What are DNS servers? Actually, they are like computers that help you to open a website on your computer. Static IP addresses are considered somewhat less secure than dynamic because they are easier to track. However, following the safe internet practices can help you to keep your computer secure no matter what type of IP address you use. Let's talk about routers. A router is a device that analyzes the contents of data packets transmitted within a network or to another network. Regardless of their function, size, or complexity, all routers are essentially computers. Just like computers, tablets, smart devices, routers also require CPU, OS, memory consisting of RAM, read-only memory, non-volatile random access memory, and flash. A router has access to volatile or non-volatile memory storage. When a host sends a packet to another host, it will use its routing table to determine where to send the packet. The routing table of a router can store information about directly connected routes, remote routes, and default route. Directly connected routes come from the active router interfaces. Remote routes come from remote networks connected to other routers. Default route is as a last resort if there is no other route to the desired network in the routing table. Let's look at example. Suppose host 1.1 wants to send a packet to host 4.1. When the packet arrives at router A consults its routing table to find the best path to network 4. Router A forwards the packet to router C as specified by routing table since the metric is 2 hops. Router B can deliver the packet to network 4, but it would take 3 hops to do so. So we should take the most efficient one. When router C receives the packet, its routing table specifies that router E is the next hop in the path. When the packet arrives at router E, the routing table indicates that network 4 is directly connected, so router E formats the packet with host 4.1's MAC address and delivers the frame to host 4.1. If this video was useful for you and you learned something from it, please like this video and thanks for watching.